Alright boys, this week I've been sticking my fingers in the spinning wheels of pain that is AI in Unreal. And I just thought I'd kind of give an overview of what I'm doing and maybe point out some tips and tricks that might help you in the future to optimize the behavior tree. I think I'm doing some things that are generally a bit against the grain, but that I found really useful in cutting down the bloat, the spamming, and keeping your behavior tree quite simple. So yeah, stick me on 1.5 speed and let's have a look. So I'll just quickly go over what my AI is doing, or at least what I want it to do. I'm just going to start with one enemy opponent. So they're wild animals, in this case wild dogs. You can obviously see there's no animation on this character. So when they spawn, you get a roaming sequence where they just pick a random location, move to it slowly. Okay, it's going in the doorway. That's going to ruin everything. Then when they see the player, he'll turn around in a second. They go into an aggressive mode and they follow you around. And then once they find you, they stand at a distance from you, at least one animal will, and bark to signal to other animals. Okay, now you can try and run away, and if the dog loses you, it'll remember the last location you were at, travel to that location, and if it can't see you there, it will then go into a hunting mode where it follows a scent trail, which I'll go into later in the video, and it's sort of got a few seconds to find you on the scent trail, and if it can't, it will go back into roaming mode. It'll assume you've gotten away, and then the whole process can start again. Things are slightly different when there's multiple enemies, but should be pretty predictable. Okay, so if one sees you, he calls out, and that call goes out over a certain distance, and any other animals in the area will then go to that dog's location until they can see you, at which point they'll then follow you around like this. But the same applies. They follow you, and you can try and hide and get away, and they'll go into a hunting mode. And it's much harder when there's more animals, though. It's much more difficult. So, okay, so the first thing I want to go over is just what happens with the AI controller when you're spawned. Like I said, this video assumes you know something about behavior trees and AI in Unreal already, and I'm just going to go over some refinements that I made that might help people who are trying to push their understanding of behavior trees and AI a bit further. So what happens when the AI controller is spawned is that you run a behavior tree, and that's most YouTube videos I've seen will tell you to run that. But what I found helps is, you just keep variables on what the blackboard is to save you doing multiple calls for other things. You make a variable of that. You make a variable of your controlled pawn. Then what happens here is, this is how I'm controlling the group behavior of the animals. So what I have is a blueprint called AI Collective, and this handles scenting and group sight. So instead of each animal forming its own array of scent locations, this blueprint just has as soon as your player is hunted, it begins tracking a scent trail. So every second, all it does is every second it makes a marker, it makes a record of where the player is and puts it in an array. And then what can happen is, whenever a new enemy needs to smell for where you are, it calls to this blueprint and asks for the next set of scent points in the array, and then it tracks you from there on in. So it's just one blueprint keeping one array rather than dozens, because I can spawn like 50, 100 enemies all at once in one area, and if they all want to keep an array of scents, it's going to be a massive drain per tick. So I'm just doing that anyway. So all that's happening here is I'm checking the level, to see if the blueprint exists. If it does, then make a variable of it, keep track of it. which is the is valid check. If it doesn't, then spawn it and then make a variable of it. So basically, as long as there's enemies spawned at runtime, there will always be one of these AI collectives spawned at the same time, and there'll only ever be one as well, so each animal won't spawn a new copy of it. So yeah, one thing I found really useful is just after you've initialized your AI controller, just put a delay of a second. It could probably be half a second or even 0.2, but after that delay, then just set a bool that says the initialization is complete. Then what I do is, for all these more detailed checks that are happening at runtime, just put a bool branch at the beginning that that relies on this bool being true, because otherwise I've found the AI controller can start firing off events before the behavior tree is loaded in, and you just get errors. You just get these kind of compounding errors that seem to bog the whole system down, whether they get stuck infinitely or not, but you get errors, and that just avoids them. It makes sure that everything is up and running fully before any events start firing, especially this perception event, because it's really twitchy, this one. So yeah, that's pretty useful. So the next optimization I like to use are gated changes, gated variable, or more specifically gated bool changes. What the behavior tree is doing most of the time is just changing simple variables, mostly bools, to true or false, because that's how the behavior tree operates. It's constantly looking for statuses that are either true or false, and then that's how it decides which branch it should go down, and then subsequently what behavior the AI should exhibit. The thing about that is that the behavior tree runs every tick, and you can often I try to avoid it as much as possible, but you can often get spamming where the behavior tree doesn't quite know where to go, and it gets kind of stuck between statuses, and it starts spamming checks. So every tick it will check, like you might have it set to like find out whether you're in direct line of sight with the player pawn, in which case it will just spam that check and it will bog the system down. So in order to sort of mitigate that, because it's very hard to avoid, I use like a gated check, where if, for example, like here, this is the AI sight perception, and all I'm doing is, whenever this is my own little take on it. I tried some from other YouTube videos, and I found I got a lot of false positives, like the AI could see through walls or see behind itself. So this is how I've got it set up. So basically, whenever there's any perception updated, and I'm only using sight at the moment, but I will bring in hearing at some point. Whenever that's updated, check the array of currently perceived actors for the player pawn. So if the player pawn is within the currently perceived actors, set the bool to true. If it's not, then don't. The perception thing, I don't know whether it's a bug or what. However it's written in Unreal is very twitchy. It will very often go backwards and forwards, or just keep giving you the same result over and over again every few ticks. It's not very consistent at all, especially when you're on the peripheral vision of an AI. It will spam a lot. So basically what I have done is I've just created this gate which just checks whether the new bool result coming in is different from the last, and if it isn't, then ignore it. So it will only change one way or another. It will only go backwards and forwards. It won't constantly spam the behavior tree with the blackboard, I should say, with new variable updates. It will only update changes. So you save like a lot of extra spam this way by just having gated checks. And I do that at the other end as well. So this sight perception thing is actually is feeding into the blackboard. So it changes the blackboard, but later on in a minute I'll show you how the behavior tree is also changing the variables in the AI controller. So there's a backwards and forwards. Sometimes the AI controller is changing the blackboard. Sometimes the behavior tree is changing the AI controller. But in each direction, I have these gated checks. So here, for example, is I made a custom event called a behavior tree event, which is basically when the behavior tree decides a variable should be changed, it changes it on the blackboard and then tells the AI controller, hey, I've changed some variables, you need to update, and you get an event. Then what happens is every variable that is necessary is checked, and if it has changed, then subsequent things result. So it then does things like calls out to other AI, it talks to the AI collective blueprint, and it talks to its own character blueprint. So all these different functions here are just whenever anything, basically all that's happening is, get the ball, check it against your own version of your ball, and if the two are different, change it and then send the message. But if they're not different, don't do anything. So these are just more. This is just another version of the gated check from up here, but it's a gated check between the behavior tree and the AI controller. So it's basically saying get the ball on the behavior tree, check it against your own version of the ball. If they're different, change it and send a signal out. So that could be something as simple as you saw in the demo, that the color of the eyes change in the animal, which won't be in the final game, it's just for testing purposes. But that message needs to be sent out to the NPC character blueprint. So here you can see cast to control pawn, wild enemy AI, wild animal enemy, which is a character blueprint, and then it changes the state to roaming or changes the state to following. So yeah, ball checks. These are pretty useful to avoid spamming or mitigate the effect of spamming anyway, which I'm also trying to do in the behavior tree, but it's not always possible. There's usually some fringe cases where the behavior tree will get locked into a cycle briefly and spam the checks every tick. Alright, so staying on the subject of spamming, the behavior tree itself likes to spam. And a lot of the YouTube tutorials I've watched, I keep saying YouTube tutorials because there's very little documentation on this stuff. It's just seems to have been a lot of trial and error from the community on how to actually use this stuff properly, which is good for me because it means I can interpret it how I want and do things how I want, which may be Epic's intention. But yeah, it likes to spam. It likes to well, I suppose what makes it a lot worse, and what a lot of people don't realize, is that the behavior tree is moving kind of differently from flows in regular blueprints, in that they go one direction and then end. So they start on the left, they move through, and then they terminate on the right, unless you will give them a loop or give them some other command. Behavior trees, because of the way each node works, they effectively move in and out. So the call comes down from the root, goes to the first on the left, moves down, and then it will move through these nodes, and here's the roaming behavior here. So get random, control point, move to it, then wait. Yeah, very simple. But what happens when that's done is that the flow then goes back up, right back up to the root, and then comes back down again. So it's actually looping each time, which can lead to extra spam, but you can also use it in your favor, because what I haven't seen in a lot of online tutorials is people harnessing that outward call. I found that outward call can be very useful. So when you're making services or tasks or decorators for your nodes, you can take advantage of those outward calls. So what I've done here is, it looks like a load of spaghetti, but it's fairly simple. What this does is it first does something on the activation event. So that's the call going in. So it's coming down from the root and going in. And then it also does something on the the deactivation. So on the call going out, and you can do a lot with that. So what this is doing is it's saying, what it allows me to do is, if I open up the options for it, you see here on the left, I've just got a series of 4 groups of booleans or bools that I can set to true or false on entry or exit of the node. So here I'm saying, okay, well, if we're entering this node, set roaming to true, right? And then as we're leaving, set roaming to false. So I don't need to worry about setting that variable to false anywhere else in the network, because I know that roaming will only ever happen within this node, and anytime we leave that node, roaming will be switched off. So that's the basic function of this set of this spaghetti here. But what's also happening, what I can also do is I can set multiple variables. So I can say on the way in, if I don't hang the entire system, I can say set, let's say, like, I don't know, calling. I wouldn't do that here, but yeah, I can set calling, and I can set to true on the way out. I could set like out of bounds, let's say. So what I can do is I can have a total array of different variables that I can set in and out, and that's really useful as your tree gets more and more complicated. So the more variables you've got going on, and the more states that the AI can switch between. So it might have like a feeding state that's a subcategory of roaming. So it might find food and start eating it as a part of like extra behavior. Well, that adds complexity to the tree, and what might happen is from feeding, the AI sees the player, then it has to immediately jump to a new node over here on the right of the graph, and in doing so it has to switch off all the variables that might have been going on over here. Well, that's what that in-out variables service is really helpful for, is that it allows me to set and unset whole groups of variables really quickly, going in and out of a node. So yeah, that is very powerful. And so all that's happening in here is it's saying it gets, so this is for the group of variables that are true. So it says if this array is not empty, go through each one and set the blackboard value to true, then add 1 to the bool change count, right? Then it's, if there's any false, do the same thing, go through each one, set them all, and add to the bool change count. And then if by the end of both of those checks there are any bools to change, so even if only one of them is set, this bool count will change to 1. Then it basically tells the AI behavior tree, see we're casting to the the AI controller. It says, hey, I've changed a boolean, so you need to update, and that goes over here, goes into this tree. If there's nothing to change, it won't send that command. So if I were to go here and I would delete both of the variables in this array but leave this service there, it wouldn't do anything. So it would run a check and it would go, okay, that's empty, I don't need to do anything. So that's again an optimization of just checking that there's anything to do first before doing anything. And then this one is exactly the same, but on the way out. So you can see they're twins of one another. So this is just on the deactivation. It checks if there's any bools to be changed on the way out, and it does the same. And then if there are any of that have changed, it tells the AI controller, hey, I've changed some booleans. The AI controller goes, okay, let me check that. It runs through, checks them all, and goes, yeah, okay, 1 has changed. And then it sends the relevant message. So it's at every step of the way, it's just doing a check to make sure it's not being spammed. It's not receiving just the same results over and over again. And yes, it's also changing variables using both the in and out flow of the behavior tree. So yeah, I found that really useful. Next up is infinite loops. So a lot of the tutorials I'd seen kind of leaned into this idea that you let the behavior tree spam away at the check until something changes. But I think what I've found is that the problem with doing that is that for nodes further down the tree, you're having the behavior tree spam these other checks that don't really need to be done. So if I wanted the behavior tree to keep constantly going backwards and forwards every time this patrol began and ended, it would have to run these other checks. So if I had complex services, or decorators running on these nodes, they would be checked without any reason. They would just add to bloat. So I found the infinite loop to be your friend in this scenario. So where I could, I introduced infinite loops. So you can see at the endpoints of all these behaviors is a loop that's infinite. And what is quite cool about behavior trees is that, well, let me explain the advantage with the loop. So what will happen is, instead of every tick the behavior tree shooting backwards and forwards and running these checks, what will happen is the behavior tree will come down, and then it will just stay in this loop infinitely, and it won't be spamming the rest of the network. So it will just stay looping this. But what's cool is that if you then feed in a different, so this one relies on cannot see the player. So if my AI controller came along and changed that Blackboard variable, can see player here, it would break the infinite loop. So it would actually, it does still behave like the behavior tree normally would, but without all the spam. So it would then break the loop and move the behavior tree on to where it needs to be. So you don't have to have the behavior tree constantly cycling. It can just go down into a loop and stay there, and it will still work if a Boolean changes. So yeah, loops, infinite loops. So this one is where this loop is for the roaming. This loop is the distance check. So what happens is here is that when the player is seen, the dog tries to get to within a certain range of the player. And when it's in that range, it will every half a second just do this check. Where's the player? Where's the player? Where's the player? Is he more than 600 units away from me? If not, just continually loop that. And as soon as that becomes true, it will then move to where the player is. And it will continue to check again. But like I said, it's quite a quick check, it's half a second, but it's not doing all these other checks along the way. And then over here in hunting, it's the same as roaming. Get the next scent location, move to it, and then this is the countdown timer for how many goes the dog has before he gives up. So it's I've set 5, so he can basically move to 5 points before he gets bored and moves away. But obviously I'll vary that with the difficulty of the game, so that's something I can tweak later down the line. And yeah, same here as well. When the dog is answering a call, so when it hears other dogs calling, it can move 3 times, so that's just 3 loops there before the dog gives up and goes back to where it was. So yeah, loops, use them. So I'll just cap off by just showing you a short gameplay demo whilst showing the behavior tree at the same time. I'm sorry that you can't read the nodes, but you should just be able to see how the tree behaves and see that it's not flashing or spamming. It should go to each section in turn and stay there for the right amount of time until it's ready to move on to the next section. I've just got one AI in this version. So you can see the roaming there. Just staying in it. Yep, it's just going between those respective nodes as needs be. So if he sees me, he'll then go to following, and then go to waiting. Then there's the looped distance check. Okay. And if he loses me, he'll go to the last location, then he'll go to hunting. You see how the tree stays in that place. It's not flicking between other branches. And now he's just gone to roaming again. So yeah, that's just how I've kind of tried to tame the tree so it's not all over the shop and it's not testing loads of useless nodes along the way. It's just doing exactly what you want it to do at the right time, and there's not too much noise, and it's much easier to test as well, to debug this way, because you're not looking at constantly flickering, altering output in the debug. You're just getting solid, consistent behavior, and errant behavior shows up really easily when you control it this way. So yeah, so that's about it for now. If there's anything anybody wants to see about this setup, let me know in the comments and I can do another video going over any particular part in detail. But yeah, hopefully that was helpful, and I'm sure there's loads of people who are more knowledgeable than I am about behavior trees screaming at the screen telling me that's not how it should be done. But yeah, I guess let me know down in the comments and I'll try and respond.